Hello my dear students, welcome to Eshwari channel. This is your Eshwari ma'am. Students, in this video we are going to see what is the closest distance of approach. In short, it is CDA from the chapter Atomic Structure. So first let us see what is the meaning of CDA. Students, consider an atom. So here we have an atom and here this is the nucleus. So what is the charge for the nucleus? You know that nucleus will be positively charged. So nucleus is positively charged. So let us take the charge on that as Ze. What is Z? Z is the atomic number and E is the charge of the nucleus. So Z is the atomic number and E is the charge of the nucleus. Okay, charge, you know, it is due to the presence of protons in the nucleus. So now we have considered an atom and now let us take here alpha particle. So this is alpha particle. So students, you know what is alpha particle? Alpha particle is helium nucleus. So He, helium. Helium atom has atomic number 4, mass number 4. So meaning is helium atom will be having a nucleus with 2 proton, 2 neutron, and there will be 2 electrons in the shell. So if you remove this electrons, only the nucleus, we call it as alpha particle. So what is alpha particle? The nucleus of helium atom is called as alpha particle. It will be having 2 protons and 2 neutrons. There are no electrons. So this alpha particle, you are accelerating towards the nucleus of the atom. So here the position of the alpha particle is at infinity. So this we have taken at infinity. So if it is at infinity, there is no attraction or repulsion between alpha particle and the nucleus. So now let us take this position, that is at infinity, as position 1. So here this is position number 1 where alpha particle is present, that is at infinity. So now start accelerating this towards nucleus. So you know that alpha particle is positively charged. Nucleus is also positively charged. So positive and positive, that is same charges, you know that they will repel each other. So as the alpha particle come close to the nucleus, there will be more of repulsive force. As a result, they will be deflected. So here they will stop here and then they will get deviated like this. So after this, they cannot go towards the nucleus because both are having same charge. There will be lot of repulsion between them. So here this point from here to the nucleus, we call this distance as CDA, that is closest distance approach. So here let us take this as R0. So what is R0? R0 is the closest distance approach of alpha particle towards the nucleus of the atom. Okay, so let us take this as position 2. So what has happened, once again see here, we have taken a alpha particle. So alpha particle will be the nucleus of the helium atom. So we have taken at infinity. So infinity we have taken as position 1. So this will be accelerated towards the nucleus of the atom. So as it approaches, the repulsive force between them will increase. As a result, at one point they will stop. So here they will stop and then they will deviate. So this position we will take it as 2, where the alpha particle will stop. So now this distance, that is from here to the nucleus, the distance we call it as CDA, that is closest distance approach, and let that distance be R0. So now let us calculate the value for R0. So now students, let us see at position 1 and position 2 what is the total energy. So you know that TE, total energy, is equal to potential energy plus kinetic energy. So first let us see at position 1. At position 1. So at position 1, what is the kinetic energy. So kinetic energy is equal to half mv square. So v, let us take it as velocity 1. So kinetic energy at position 1 is half mv square. So potential energy, so kinetic energy at position 1, potential energy at position 1 is equal to, you know that between two charges, okay, between two charges where there is attraction or repulsion, the potential energy will be given by K Q1 Q2 divided by R. What is the distance here? From alpha particle to the nucleus, the distance is infinity. So here the distance is infinity, therefore this value becomes 0. So now let us calculate at position 2. So position 2, kinetic energy Ke2. So at position 2, kinetic energy becomes 0. Why? Because it will stop here. It will stop and then it will deviate. So when it is stopping, its kinetic energy becomes equal to 0. Then potential energy Pe2 becomes equal to K Q1 Q2 by R0. So here the distance will be R0. So now let us equate at position 1 and position 2 the total energies. So total energy at position 1 is equal to total energy at position 2. So students, you know that energy will be conserved. Okay, that is total energy at position 1 should be equal to total energy at position 2. That is law of conservation of energy. So at position 1, total energy is kinetic energy plus potential energy. So here it will be half mv1 square plus 0 is equal to total energy at position 2 is kinetic energy plus potential energy is K Q1 Q2 by R0. So now what we can write is, take R0 to the other side. So you will be getting R0 is equal to 2. So 2 you take to this side. 2 K Q1 Q2 divided by mv1 square. So R0 value we are getting as this. So now what we will do is, so now let us substitute the value for Q1 and Q2. What is Q1? Q1 is the charge of alpha particle. So what is the charge of alpha particle here? So in the alpha particle, you know that alpha particle has 2 protons and 2 neutrons. 2 neutrons. The charge will be only due to proton, because protons are positively charged and neutrons are neutral in nature. So the charge will be due to protons. So 2 protons, therefore charge will be 2e. So Q1 is equal to 2e. That is total charges in the alpha particle. Q2 will be charges in the nucleus, which is Ze. Ze. So substitute this in the equation. So R0 is equal to 2K Q, in place of Q1 write 2E Ze divided by M1 mv1 square. So simplify this. R0 is equal to 2 2s are 4 K Z E into E will become E square divided by mv1 square. So this is the equation of CDA, that is closest distance approach. R0 is equal to 4 K Z square by mv1 square. So using this relation we can find out the closest distance approach of any alpha particle. So let us see one numerical how to calculate R0. So students, here let us calculate CDA for this numerical. So calculate CDA, that is closest distance of approach. V1 is given and the nucleus here is copper and K value is given. So you know that the formula for CDA, that is R0 is equal to 4K Z square by mv1 square. So this is the formula we derived. So let us substitute in this formula. So R0 is equal to 4 into K is constant. What is the value of K? 9 into 10 to the power of 9 into Z. Z is called as atomic number. So here the atomic number of the atom is 29. That is for copper. So 29 into E square. E is the charge. So charge will be 1.602 into 10 to the power of minus 19 square divided by m. So m is the mass of the alpha particle. So what is the mass of the alpha particle? I said you that alpha particle is nucleus of helium atom. So inside the helium atom there will be 2 proton and 2 neutron. So the mass of 2 proton plus mass of 2 neutron we have to consider. 2 plus 2 will be 4. So 4 into, you know that mass of proton and neutron will be almost equal. A slight difference will be there, but you can take it as almost equal. So it is almost equal to 1.66 into 10 to the power of minus 27. So let us substitute that here. 4 into 1.66 into 10 to the power of minus 27 into velocity. Velocity here it is given as 2 into 10 to the power of 5 whole square. So this is how you will substitute. So this is equal to 4 and 4 you can cancel. And later on you can simplify this. So if you simplify, you have to get this answer. You will be getting 1.008 into 10 to the power of minus 10. So when a problem is given, so you can use the formula and then simplify. So hope students this video is useful to you. I'll meet you in the next video students. Bye bye.